In this demo, I'm going to show you the limitations of extension methods in action. I'll show you that you can only extend accessible types, and then how your extension methods can only use accessible members in the target. And finally, that extension methods lose out if they clash with a matching method signature in the type hierarchy. I'm going to use a couple of simple classes as the targets for my extension methods. This class is called target, and it has a private field that stores an ID, and that has a protected property for child classes to get or set the value, and a public method to read the value. I also have an internal class, so this is only accessible inside the same assembly. And that internal class has a nested class which is protected, so I'm just using this to show you how accessibility applies with extension methods. Okay, so I'll create a new sponsor class called target extensions. This will be a public static class, and it's in the same assembly as the target types. That makes internal classes accessible, so I can add a static method called extendInternal, which targets the internal class. Now this is fine, I could add a method body here and do what I want to do, but the method itself can't be more accessible than the type definition, so I can't make this public. The most visible this can be is internal. So if you need to do this for internal classes, you can, but your sponsor class has to be in the same assembly as the type you want to extend. There's a limit to how useful that is. You can't extend internal classes in third-party libraries, but you could use it to add some cross-cutting concerns to interfaces in your own assembly. Nested classes might be different because they have their own accessibility. I'll copy this method and call it extendInternalProtected, and I can try and target the protected nested class. Now I get a compiler error saying the type is not accessible. Remember, the sponsor class is not part of the hierarchy of the target type. I can't access that type because it's protected, so it's only accessible to child classes of the internal target. Okay, I'm going to leave that now and show what accessibility means inside the extension method. I'll add a new public static method which returns a string. I'm calling this getStandardizedID, and it will extend my target class. Just as a reminder, here's that class where the only public member is the getID method. This method will return a standardized representation of the object's ID. To read that, I can't use _ID because it's a private field. I can't use ID because that's a protected property. Neither of those members are accessible to me in this extension method. I have to use the public getID method because that's all I can see from this context. So just as a simple example, the standard ID I'll return will be uppercase. The last thing I want to show in this demo is how extension methods can get hidden by class methods. I'll show that in my tests, switching back now to my test fixture here and adding a new class for my target tests. I'll just have one test in here, which will execute the standardized ID extension method. I'm going to create a target object with a known ID, and I'll add my using statements here for NUnit and the extension library. And then assert that I get the uppercase value of the ID when I call the getStandardizedID extension method. Run the test, and that's all fine. So far, so good. Now, fast forward a few months and say another developer on another team needs to get a standardized ID, and they don't know that my extension method exists. So they edit the class, add a new method called getStandardizedID, and they return a standard value, but their requirement is for this to be lowercase. Everything compiles, but this type method has the same signature as my extension method, so it's going to hide my extension. Now, when I run my test, it's going to fail because I'm expecting an uppercase value from my extension method, but actually I get the lowercase value from the class method. Visual Studio knows which method the call is binding to, so I can follow the definition here and confirm that the new class method takes precedent over the extension method, and so the extension method will never be called. I'm lucky because I have a test for this, so it will break the build. But you can imagine how difficult this would be to catch if this situation happened because of an update to a NuGet package which added a class method that hid my extension method. So extension methods are simple to use, but you need to follow good practices to avoid the sort of problems which take many hours to debug. With that in mind, I'll end this module revisiting how extension methods help you write better code.